Good morning, my name is Bruno Cornaglia and I work at Vodafone, where I am the Fixed Access Senior Manager for Fixed Access and managing the roadmap and the innovation for all access technologies. I'm also the chairman of SDN NFV work area at Broadband Forum and also the chairman of Fixed Broadband Project Group at TIP. And for us, the Telecom Infra project, and in particular the Fixed Broadband Project Group, is really important because it gives us the opportunity to set up and define common requirements among all operators for disaggregated hardware and software of fixed access, including BNG. And we are really excited to see the next step that are the technical document for testing for OpenBNG and to issue the technical requirements for open fixed access. And we are expecting this to be done in 2023. Thank you very much.
My name is
All right. Welcome, everybody. It's great to see Bruno at 8:30. Bruno is like Italian espresso, like bitter, but gives you a boost of energy, like very appropriate. So you might be wondering why is this guy doing the opening keynote? One of the reasons is that Hanson and Andy, who are like around there, have a terrible criteria selecting speakers, at least for the first one. And the second one is because nobody else was available at 8:30 in the morning, so that's the only reason. But let's get into it. I want to start by thanking all the OPT and fixed broadband members. If you ask people around in TIP, people that has been part of the community, I think OPT has, and fixed broadband now has set up a standard on how the industry should work together and how people should come together to define how the future of connectivity in these domains should look like. We have a strong foundation with co-chairs and co-leads in the different subgroups that give us that energy and that vision that project groups like Fixed Broadband and OPT need. So let's get started. We are going to discuss about what's been going on in the fixed and transport networks industry, and specifically around TIP in the last few months. Obviously, we all know that fixed and transport are technologies that are fundamental for the connectivity these days. And when TIP started its journey, it was very clear that we had to do something about them as well. It was not about changing how access networks, specifically mobile networks, work, but it's the end-to-end stack. So back in 2016, a group of great individuals, you can see some familiar faces that are also sitting here today. Anders is one of them. I'm sure he recognizes the picture. They got together and they decided that, hey, we have to do something. Transport networks are very monolithic. They are single vendor most of the times and so on, and it's time to change that. So we started very small. I don't know if you guys remember, there was an initial project called Voyager. It didn't go too far, but it was a good way to try it out, get the people together and so on. And soon we started developing more subgroups, and we're going to talk about those in a while. But things like PSC, GMPY, and all the tooling that started from those discussions are kind of the foundation of the work that happened in OPT and that then derived into fixed access. So, but we want to talk about why fixed and transport networks are so important, right? We all see, especially the people that has been working in this domain, that transport is most of the times taken for granted, right? Yeah, they call them the pipe, right? They only remember that pipe when it's not working, but transport networks are way more than that. They are the core of every connectivity. You can have fantastic base stations, better if they are Open RAN based, or you can have Wi-Fi access points, OLTs. You can have the core sitting somewhere in the middle of your network, but unless you have something to connect those, nothing is going to work. And that's essentially the fundamental mission of transport networks, connect the different components that you have in a network. Additionally, this thing has some lag. The supply chain was, especially like a few years back, very reduced. And obviously that reduces competition, which is something that we don't like as an industry for two reasons. Obviously, everybody's concerned and worried about pricing of these solutions, but it's not only that. When you don't have enough competitors, innovation doesn't happen as fast as it should. So we started our mission in OPT, trying to bring more people, more companies into the mix, right? Destroy or remove those blockers and boundaries that we have in the transport domain and in the fixed access, and bring more vendors into the equation. But obviously, all these solutions have to fulfill a customer demand. Sometimes those customers are enterprises. Sometimes those customers are internal teams within the operator's network. But there is always a customer there demanding for connectivity, demanding for more capacity, demanding for less latency. And we have seen that evolving along the years. So with more services, more use cases, and so on, the transport network and the fixed access networks have always to catch up to fulfill the requirements they need. Additionally, we have also seen these long bills. Those who run RFPs and RFQs at operators have reviewed TCOs and so on, and sometimes I got scared, especially when they were checking the operational part, installation, commissioning, and then integration with OSS and BSS systems. So you will see that in a second, but one of our principles is that all the technologies that we wanted to develop had to be fully open and disaggregated to remove all these interoperability issues that you could find with traditional solutions. So this is essentially what we did. We broke out the problem into layers, starting with disaggregation at the very basic level, hardware and software being separated. The main advantage of this model is that obviously you can combine a solution from different suppliers at your own will, right? And that's ideal. You go into a selection process, an RFP, an RFQ, and you have multiple choices you can pick from. You have 3, 4, 5, 6 hardware vendors and the same number in the software, and then you mix them as per your requirements. Then obviously we want to make sure that the vendors that come into the disaggregated journey have a strong future, right? And that comes with volumes. Nobody invests into developing a technology unless that technology is going to get some profitability back into the supplier, right? And otherwise, the CFOs are not going to be happy. And as I said at the beginning, interoperability and integration with SDN systems, management system, call it however you want, was also fundamental. So all the solutions that we've been developing along the years had a very basic requirement top of the list that has to offer open and standard-based APIs. All right, there was an animation there. So as I said, 6 years in the making. We started OPT, as I said, with Voyager, and now we have more than 10 subgroups running different tracks within them. I am particularly proud about this journey because I have, if we take Voyager apart, which was again the first experiment, all the technologies that were developed within the OPT community have been commercially deployed. We have commercial deployments in almost every corner of the world. We are not putting the numbers here right now because they are going to be on main stage later on, but we have more than 50 commercial deployments with the different technologies that we have incubated during the years. We have multiple operators deploying and testing these solutions as we speak. We have more than 100,000 devices deployed in networks all around the world. So that's obviously something that makes us very proud. And we couldn't have achieved all this without the community that we created. I think apart from building all these devices, bringing the operators and suppliers together, what we built is a group of like minds that think in the same way, and that's at least from my perception, has changed the industry forever. It's never going to go back. I remember like 4 or 5 years ago, most of the operators wouldn't look inside the box and see what was in there, what's the chipset, what are the components, and so on. Now everybody does it, and they are fully aware of the hardware they are buying, the software they are buying, and so on. And that came with disaggregation. All right. Let's talk about the fixed and the transport networks and all the stuff that we've been doing recently. It's important to highlight that as we continue in this journey, we don't want the piece of innovation to slow down. We want to continue to grow. We want to develop more initiatives. Now that this new paradigm and new way of building networks has been established and adopted by the industry, we should go a step beyond. It has to become the de facto model of building transport networks. So in the last few years, we got 32 deliverables published. I think that's something that should make us very proud. Those documents are not like a couple of pages listing wishes and so on. They are detailed technical requirements, both for the hardware, the software, the SDN interfaces, and so on. Documents that the industry can use as a reference. And the best part of those documents is that they are completely operator-driven. That means that they fulfill or they give a vision of the requirements the operator have for their networks. And one of the main characteristics is that they are also vendor neutral. So when a vendor comes into the OPT community and they see a list of requirements, they know perfectly that it hasn't been baked or influenced by their competitors. On top of that, you guys know that we started this test and validation framework some years ago. We wanted to make sure that adopting technologies like the ones that OPT and fixed broadband develop could be as easy as possible. So essentially, we established tip exchange, the ribbons and the badges as a way to demonstrate to the industry that solutions were becoming mature, right? We wanted to achieve an end status where an operator would go to tip exchange, see a solution that has a gold badge or a ribbon, and they know that that solution is going to work perfectly as soon as it gets plugged into the fibers or the power cords in their network. And we have more than 43 tip solutions and badges out there. And obviously, we created almost, like 2 years now ago, the Fixed Broadband Project Group. We all see that the relevance the industry is giving to a fixed broadband continues to grow. I think this whole industry was too mobile-centric for a very long time. Now people has come to realize that, wait there a second, 70% of our traffic, give it or take, comes from the fixed access and not from the mobile. So obviously we wanted to do something there as well, because it's a very fundamental domain. For the services that we all consume today, streaming, video calling, working from home, all that stuff, but also the services that are going to come very soon. And that's all from my side. I think, again, I want to finish the conversation and the inaugural keynote, thanking our co-chairs, thanking our co-leads. I'm going to pass the mic to one of them right now. And welcoming to you guys all. It's been a journey. We want to continue. We want you guys to be part of this journey. So thanks a lot. I think I'm going to now pass the mic to Rafa Canto from Telefónica, who leads the fixed broadband PG together with Bruno. And he's also part of the TIPS technical committee. So Rafa, all right, technical issue. We're getting there.
Right, technical issue, yes. Okay. Thank you. So, can you hear me? Yes. So, hello everyone. It's a pleasure to be here. So, thanks Diego for the inspiring gastronomical insights on the transport area. I'm here. I'm gonna provide an update on the activities that that we are doing at the Fixed Broadband Group. This is a new group. It's been running for 12 months, more or less, and we did many things already. So we are excited with all the advances that we had in the group these times. So first of all, why? So we were working on different in TIP. I was not part at the beginning in 2016, but I've been seeing how this community has been growing from 2017, 18, 19. So each time there are more and more people here. So this until we are in this moment with this great event that we have. So we have been extending the scope of the tip areas that we are working, and we are more or less covering most of the network. We have Open RAN radio, we have mobile backhaul, we have wireless backhaul, the core network, also the transport part and the routing part. But there was one piece missing, and it's very important, as Diego mentioned. This is the part in which we are doing the fixed broadband. So we were focusing for the services of our commercial customers, and we decided that we should have an open BNG product. We should have an open OLT product, both in order to provide gigabit capabilities to our residential customers. So, as said, our focus is both OLT and open BNG. In the OLT, we were working on white boxes, on pizza boxes, that we will be able to provide GPON or XGPON capabilities. We were working on transition architectures and also providing disaggregation. So TIP is all about disaggregation. So our objectives are very similar to the ones that we have in here. So we will be doing both vertical disaggregation and horizontal disaggregation. In vertical, the decoupling hardware and software, and sometimes also decoupling the architecture. As we are, for example, doing in OpenBNG, in which we have some disaggregated also architecture. So as said, our work areas are those two. So in fixed access, one of the key components, apart from disaggregating hardware from software, it's the programmability. We want this to be a solution that can be easily integrated in our networks, and for that, SDN is key. We are working on how to integrate this into our network in a smooth way, and we are considering these transition architectures. And the idea is that we can have this possibility of mix and match different components in the solution. Regarding the OpenBNG, again, we also are working on this disaggregation from hardware and software. And one of the things we did is we consider here all the requirements that we had for an operator. We want to have a modular approach in which we will be able to build with different components all the different use cases that are there for operators. Some of them are some of the operators are building these solutions centralized. Some of them are building them distributed. Some of them are providing just BNG services. Some of them we are doing it including also PE functions. So it's a kind of service router. So the idea for us was to build a solution as flexible as possible so that any kind of deployment could be included here. And we also made a great effort on providing these SDN capabilities that we require for automation. So for including new technologies, as Diego commented, open interfaces are key. We need a way to be able to put in our networks new technologies very easily. And for us, programmability and open interfaces is key for that. So our objectives in the PG. So again, we want to put a set of requirements developed in a collaborative way together, so that we can provide the vendors interested a complete picture of what these operators require, and that they will, with that product, they will be able to satisfy all these demands. So, and our idea is to increase, of course, to increase the diversity in the supply chain, to protect it, and to provide new opportunities and new possibilities of choice. So, In everything we do, we take into account the interoperability, the modularity, the simplicity, the sustainability, and the flexibility. The idea here is that we will be able to mix and match the different components that they need to operate. We all have heterogeneous networks, so we need to be able to integrate them very easily and in a modular way. So sometimes we will require more functionality or less. So, and this is one example that we are doing in OpenPNG, for example, when we are creating software packages that can be or not. So, having said that, so what have we done in these 12 months? Many things. So we created a group, and we were, first of all, we were working on OpenPNG in the OPT group, although we decided that it would be better transferred to the fixed broadband part. We had been working in a first RFI version, but we completed all the functionality that was already there, creating also this programmability component that we will be inheriting from OPT. So all the important part is that those open interfaces are the same ones that are being developed in OPT, so that we can have a common substrate of programmability across all the functions. Ideally, across all the functions also in TIP, that this is something that can be extended. Also, we are taking all these routing capabilities that are part of the OPT, and we are putting in OpenPNG. This is the same functionality, this is the same layer, so that again, the IP routing functionality is a common substrate across can be across a common substrate across all layers in all functions in TIP. So we added also, because you know that we added the caps possibility. So there is an implementation option including caps, control plane and user plane separation, that we are seeing that it's a very important piece for the future. Not every operator will be willing to go that way in the straight away, but for sure this is something that it's ahead. So we introduce caps as how a caps interface should be implemented and commercialized in a product. We are not defining standards in here. We don't want to define anything new. What we want is to use what is already there. This is something that we are doing consistently in TIP. So we are inheriting all of this from the work that is being done in BBF. But what we want is to have commercial products including all these functionalities. So we published this RFI end of 2021. Then we had a short list in December, and now we are in position that we have the first OpenPNG products already in our labs. So we are all testing different solutions. We are complementing how we test and the use cases that we are interested in. And as of today, there are already 4 OpenPNG evaluations ongoing. So the idea here is for us is to help mature those solutions, to be with the vendors, to test with them, to check what's working, what's not working, and how to progress. So what we have been seeing is, as we have seen in other initiatives in TIP, is that everything is progressing very quickly. The development is being very agile, and we are very happy on how it is evolving. So we see this capability of innovation that Diego was also mentioned before. Regarding the open fixed access, this is even newer. We created the group in February, and the idea is to work on disaggregated OLT solutions. So we have published the first use case document, and this is something that I think that it was announced yesterday. And I can say that we are very close to completion of the technical requirements document. So probably in a few weeks, we will be able to publish it. So to submit to the PGs and then to publish it. So lots of things going on in this year. And what's next? So first of all, now I'm feeling like in the Oscars. So we are pleased to announce that there are already requirement products that are fulfilling the criteria for the compliance of the ribbon, and we are in the process of being able to award these ribbons to both EdgeCore and UFI Space. So that they have been working with us and providing the solutions that we require. So we are extending the use cases. We are extending the test cases that we are producing. The idea is to produce a very complete test case that maps with the test plan that maps with all the detailed requirements. And we will be releasing very soon. So, and the important thing is that we look forward to any new contribution and any new partner that wants to join us and wants to be in the lab and testing. So this will be most welcome. And regarding the open fixed access, this I already commented. So we are very, very close to finishing the technical requirements. In this, we have completed the requirements for this fixed for farm or OLT that can be either deployed in a strict cabinet, and it will be able to provide GPON and XGPON. So this coexistence and this of both technologies and this transition was important for all of us. So when we release the technical document for the community to review, there will be a process in which it will be approved, and we are already starting to develop the detailed technical requirements that will be like the embryo of the RFI that will come afterwards. Because our idea is to publish an RFI, then have a short list, and then bring all the shortlisted vendors to our labs, as we have done in the OpenBNG. And I think that's all from my side. So I know that there are also specific sections on fixed access and OpenBNG, and you will have more details in there. Okay. I will pass also, I will introduce also Johan, Hjortås, and González. They are the new co-chairs, so it's also a great pleasure to have them joining the co-chairs team, and they will provide you with the dates on Open OPT.
Okay. So let's click. So yeah, it's a pleasure to be announced finally, I would say, as the two new co-chairs for the OPT project. There was some dates, 2016, just to my history in tip. We were tricked on we were invited to go up north in Sweden to visit the Facebook's new data center. They dragged us into a room and they told us a story. This is what we are trying to do, tip, together with Nokia and then Facebook and other partners, and that's where we started. I think this was 2015, and a year later, Anders was on that picture. So we have been part of TIP for a long time, in particular in the OPT. At home, I'm the chief architect for Telia company, transport optical IP networks.
I'm Oscar González de Dios, working in Telefónica, and there I am expert in SDN, so leading the SDN deployments activity in the group. So glad to be here to help and guide together with Johan OPT the next, I don't know, years maybe. We'll see.
Let's see. It's up to you guys. Yeah, so let's click. So in introduction to OPT, so this is a community of operators, service providers. I would say among the leading several of the leading operators in the world are coming together with the technology partners, where we try to, or trying, we are doing, we are building and specifying open and disaggregated technologies. And we do this with the purpose to make this technology available to us as operators. Obviously, we think that we can contribute to the bigger picture in the world by collectively describe and specify what we need as operators that another can take advantage of this. Obviously, the more that joins, the better. If you are seeking a pitch to your managers, to yourself, I can guarantee you every hour you put into tip, you get 10 hours worth back. So this is a perfect collaborative environment for us as an operator and technology partners as such. We are, though, focusing on the transport aspect. So the optical networking, so the open line systems, the open terminals. We are doing the IP MPLS with DCSG and disaggregated routers and so forth. But lately, we have also, not lately, we have started quite some time ago actually working on the tooling, so the planning capabilities and opening up and specifying the actual interfaces. So how do we go into what you work with at home with the SDN story? How do we manage these open assets? Because it's not a wanted position to bring all the complexity home to us. Lately, we have been focusing quite a lot of time in OPT with the test and validation, and we want to put the certifications and badges on the technology to make the life even easier for our technology partners, so they don't need to do the test and validation with every operator. And from an operator perspective, I can trust that Oscar, when they have qualified a solution, I can bring it home to Telia with much less effort. So very much community collaborative driven project. And now I think, Oscar, you will wrap through some of the key deliveries that we have.
Yeah, so now I'll try to, in 17 minutes approximately, to go through all of the work that we have done in OPT. OPT has been really, really, really busy. So we'll start with one of our most relevant work groups, MAST. As you know, we defined the architecture a couple of years ago, more or less. We defined which would be this common framework or this common umbrella. The ambition of MAST is that all TIP products follow the MAST specification. So we have all the products having open interfaces toward the system, so we can facilitate this integration that has been the blocker to introduce any product since a long time ago. So I wanted to tell you what have we done, where are we, and where are we going in each of these groups. So here we have been focusing on producing detailed technical requirements documents. So we have 4 processes now covering IP, optical, hierarchical, and we are evaluating more than 20 products. And we already, and this is, we are proud to announce that we have already 2 ribbons awarded to NEC and Infinera GX40. So we are very happy that we are progressing in the good direction. And now that we have these first ribbons, where are we going? So after having produced these technical requirement documents, now it's time to test them. Okay? So the next months will be really busy, not writing documents, but testing the solutions for IP, optical, that can drive SDN. And if you want more details, come back Q5, you will have a community talk with a deep dive on MAST. Okay, so see you there. Then, DOS is quite, the disaggregated optical system is an initiative to have a white box, an open transponder. And here this is our first open 400G white box. And this is quite mature at this stage. We've already had 3 trials within a big deployment now, and deployment in South Africa. So we are very happy with the progress of DOS. So now that we have already here a couple of ribbons awarded to the NOS from NEC and to the solution from Winstron, the Flex T. So now we are going in the validation phase for next year. Also, as you know, we are covering the whole picture in OPT. You might know, all of you, that DCSG is our oldest product here, so it's been mature. We started small. We covered the cell site gateway, small router. Now we went bigger. Okay, we went to the disaggregated backbone router. And we started covering the functionalities of a P router. Okay, this is what the first thing. So we designed this this leaf and spine architecture for the router, and we've been very busy testing this solution. So we have a couple of we have Drive, NetUFI, Space, and Delta solutions that have been tested in colleagues, in operator colleagues, so both in Turkcell and KDDI labs. So they have awarded an operator tested ribbon. So that means there is an operator that we can trust that has done that work. And now we think it's ready to be tested with the rest of the community. So we have already a good deployment there. And now, what is next step? Okay, so we have the P router done, and now, after having done the P router, we are focusing on other flavors. Okay, so P router is nice, but we decided to go also to cover the PE functionalities. Okay, so with this, I think we cover the whole set of potential routers that you have in your transport network. So we covered the DCSG, we cover now the PE and the P router. So here, vendors, so here, be ready, because there will be a soon launch the new detailed technical requirements documents of the DBBR PE flavor. Okay, so we will start doing next year, also doing testing, field trials. We will launch an RFI to collect the different documents, and then by mid-end of next year, do the end-to-end solution testing. So here, again, I would like to welcome you to come later to check the details on DBBR, where the experts of DBBR will be available. I'd also like to present this new group, Mantra. So you've seen that we have groups focused on solutions, okay, that delivering solutions to now. For example, we've seen in the very beginning, MAST was focused on mandatory requirements, so this is something to implement today, to do now. There were some working groups devoted to doing and to implementing boxes with some characteristics, so well-known position in the network, so that such as the DCG or the P routers or the transponder. But we need to explore new possibilities. We need to evolve. The architecture needs to evolve, and this is why we needed a group to take care of the architecture, to take care of exploring new possibilities, because we are in constant innovation. So this is why we created this metaverse-ready architecture for transport network. And here, the focus of this new group starts with the IP over WDM, the integrated IP optical. We've heard that for more than 10 years. I think all of you that are in this community old enough will have heard that for many times, but we don't know yet. So will we bet and go and say, okay, hey, in addition, we have already the Phoenix, and we already have the P routers, and we say, hey, do we really need an IP optical box? Do we really need to bet on that? Are we going to specify those as a T product? How will we do that in MAST? Okay, so we build this group to explore this and bring them later to the community. Okay, so we have this exploratory group within TIP that complements the other groups. Okay, here. So here, 3 things. Okay, so one of the things that we are exploring is the coherent pluggable market. So here, the main goal is plug and play, focusing on the openness of our solutions, that we can take in any router, put any pluggable, and make it work over the transport network. Also, focusing on which are the APIs that will need to work. We will leverage on the work that was already done for MAST. As you know, in the MAST detailed technical requirement documents, it's been specified how to interact with an open transponder, how to read the information. So we will rely here as everything relying on what was done in MAST and just find gaps. And also the third thing is to see these business opportunities, to see, okay, combining these 2 elements if we need them. So here, the roadmap in this case is a little bit different than what you've seen. Okay, so as I mentioned, the other working groups were focused on delivering products, and here, as this is more exploratory, for the next steps, we have already produced a white paper that has been disseminated. It has been presented also at ECOC recently in Basel. And now we are conducting a survey within the vendors, and we'll do proof of concept next year, and the results will be transmitted to the rest of OPT community for the next steps. Specifications in MAST, maybe new product, or additional specifications in DVBR, or DCSG, or the group that is there. This is, you know, this is our, let's say, one of the oldest members of our OPT community. You know, this is the router that sits next to the base station, and it's been there for some years. It's already in deployment. So now we are getting more hardware models, and we now have 15 products with TIP batches. Okay, so we think this is quite mature and advancing probably. So I hope that we can get the rest of the groups in the same stage as DCSG. Also, I am glad to announce that we had also the agreement on how to have the master specifications and the DCSG specifications working together. So there will be loosely coupled ribbons. Okay, so that means part of the requirements of SDN are included in the CSG requirements just for completeness, but there will be an independent ribbon also from MAST. Okay, so if you want a DCSG that functionally and also works with SDN interfaces, the box should get both ribbons. Okay, so get the DCSG ribbon and the MAST ribbon. Okay, so just to clarify. Okay, that you will need both ribbons. One will certify, the MAST ribbon will certify that it's SDN ready. Okay, then we have a couple of working groups devoted also to producing software. So the first one is PSE. Okay, so PSE, most of you will know the GMPY tool. This is the first open source tool to be able to calculate the physical impairments. Okay, so you know one of the pain points always in the optical networks has been, okay, it has been always the secret sauce of the traditional vendors. Okay, so to have all the physical impairments that you needed to go with their tool. It was always looked like a black box, so we wanted to open. For us, it is key to have one open tool that we can know the performance of our transponder. So here, this is the PSE is there for that. So now, what are they, because they have already produced the model, they have already produced software, so what are they doing now? So they are working together with OpenRODAM to simulate OpenRODAM environments. They are taking also the work to IETF to complete the models in IETF and continue to discuss with the experts, work together with MAST, so we are sure that the information that is required to do these physical simulations is available through interfaces. So you see that all the different working groups are linked together, so they are not really independent. Also with TIE, this is the transponder abstraction interface, we also need to get the parameters to be sent to the outside. So this is also a collaboration with that group, and collaborating also with operators to get better accuracy in this simulation. And in the roadmap for next year, what do we do? Okay, so we need to keep growing. Okay, so you know, 400 gig, forget it. We need to get ready for the next generation. So we'll need to go to 800 gig, and also continue working also in improving the network control using PSE. And finally, a few words about NOS. Okay, so we've seen, okay, we have working groups focusing on the hardware itself, on the interfaces, and also we have had a working group that produces a reference implementation. So this is the Goldstone. It's an open source network operating system. So we use it to fuel the first deployment. Okay, so now we see that we have a lot of NOSes already, commercially available NOSes, but for us it was very important to be able to push the first deployments. Okay, and this is why we had this NOS group that is mainly Winstron, NTT, and Palo Network working there, and it has already support for a lot of different features. So it is now working in disaggregated packet optical boxes. Okay, so it's already in production. So it's the last one of the also oldest products that we have. So I think with this we have been able to provide let's say a quick overview of all the activities. So you see, we've been ultra busy. Messages now, detailed technical recommendations are documents are mostly done. There are still a few missing, and next year will be, on end of this year and next year will be the time of testing those solutions and giving not only the first ribbon, but giving the batches. Okay, so this is what we want to do.
And maybe just to, we had working group sessions yesterday, and just as a proof to me and us how lively the community is together with the access group. There was 10 new working items discussed yesterday to bring on. So that this is what we're going to discuss, me and Oscar and the community. So what do we bring up and how do we prioritize? And then I just want to correct, I know Diego is not here. He said the Voyager did not go very far. Actually, we took it into our closed line system and we shot the signal over 1,000 kilometers. It was the world first disaggregated transponder solution that did that. So it went quite far in our network. Then, of course, we didn't get that far into the market. So.
Okay. So thank you very much, and we'll collaborate with all of you within the next years, and we'll hope to guide the group to good success. Yes. So now I'd like to introduce Atsushi.
Good morning, everyone. My name is Atsushi Ogata. I'm the president and CEO for IP Infusion. Appreciate the opportunity. Great to be here. I'd like to start with one question. So who doesn't know about IP Infusion? Could you raise your hand if you don't know about IP Infusion? 1, 2, 3, 4. All right, so probably we have done a pretty good job improving our brand awareness in the last 1 or 2 years. Only 10 people or so don't know about IP Infusion. So I think we made a good progress. So So let me jump into my presentation. So a little bit about the IP Infusion. So we have been providing network software solutions for more than 20 years. We started a business providing source code to network equipment manufacturers and the OEMs. So layer 2, layer 3, MPLS, these control plane features we've been providing to OEM customers. That has been our main traditional business. In the last 4 or 5 years, we've been focused on developing our own network OS for the white box and network disaggregation market, and that is our main focus right now. And we are honored to be recognized as a leader in the network disaggregation space from the analysts and the industry forums. A good example is the GigaOM radar report. Some of you may know this report really well. So they analyze all the network software vendors in the white box market, and we were recognized as a leader 2 years in a row. They have 3 market segments, and we are the only company who was recognized as a leader in all 3 market segments. So we are based in Silicon Valley. Our headquarters in the US. We have about 400 people globally, and we are growing rapidly. Actually, we are achieving about 100% year-over-year revenue growth this year. So these are our customer list. On the right-hand side, this is a traditional business. As I said, we have been selling a source code to many OEM customers. So I'm sure that you are familiar with many of these vendors. So our technology has been used by many of these traditional vendors. So our solution is really proven in today's network. On the left-hand side, these are the customers for our network operating system in a white box and disaggregate market. And this is not just about IP Infusion. This is something we should celebrate. All of us in this room have been talking about the network disaggregation. So more than 200 customers of IPI is adopted network disaggregation in a white box. So I think all of us should celebrate the progress we are making. Many of our customers are tier 2 and tier 3 customers, still very small deployments. But some of the tier 1 operators have been starting to adopt the white box. A good example is NTT. NTT is one of our biggest customers right now, and they are using white box in a network. On a similar note, and we are making really good progress building a strategic ecosystem partners. And again, we have so many partners from Telecom, hardware, and optics, and system integrators, and so on. Again, this strong ecosystem gives the service providers the confidence to choose network disaggregation over traditional vendors. So we want to continue to build this strong ecosystem, and many of you are working with us as a partner. So thank you for your support for this partnership. We've been working with TIP for many years now. We were quite successful in some of the projects. For example, Cassini, we have many live deployment today. We received the TIP validated solution gold badge based on a DCSG solution this year. Probably Diego is not here anymore, but we really appreciate the support we've been getting from Diego and other TIP members. We have not been able to achieve the progress we are making without the support from TIP. So our solution, Opnos, the NOS for the white box. So one of the uniqueness we have is our solution is really versatile, and we can support the multiple use cases. So starting from access, DCSG, cell-side router, we have many deployments. Recently, we have many customers who are using our NOS for the broadband aggregation. So aggregating OLT, aggregating remote PHYs, these are very, very popular use cases that we are increasing recently. And we have packet optical solutions. As I said, we have many Cassini deployment globally. We have a provider edge use cases, and all the way to the core and data center solutions. So the many customers start with one a small project in certain segment of the network, and they can keep expanding their use cases. So the beauty of network disaggregation is you can continue to use just one NOS, and then you can use the different hardware to meet your requirement for different part of your networks. So I would like to share some of the customers that we have. From the left-hand side, so Netomnia in the UK is one of our biggest customers right now. They are using, again, for the broadband aggregation solutions, aggregating the OLT. They are growing really fast. They are, again, one of our biggest customers in UK. They are working to cover 1 million premises across the UK. The second one is Lintasarta in Indonesia. They are one of the biggest service providers in Indonesia as well. They're using Oconos for the aggregation router and the data center solutions across Indonesia. The third one is interesting one. This is the Ceragon, not the typical service provider customer. They're OEM customer. But they have developed their own version of DCSG. So Ceragon has a product called Ceragon IP50FX. But they've decided to port Oconos, our network OS, onto their custom hardware and selling as a bundle solution. So from the customer's perspective, you can use Oconos based on the standard ODM platform. And if you like to use the custom hardware from OEMs like Ceragon, you can also use the same NOS on a different platform. So it's the concept of network disaggregation is still there, but you will get the benefit to have a single point of contact. They have other solutions to provide to you from an end-to-end solution perspective. So again, this is one of the solutions we have, and we have other examples. We have other OEM customers who are developing custom hardware and using our NOS on top of their custom hardware as well. And last but not least, we recently made a strategic partnership announcement with Marvell. So what it means is, we're going to port our NOS onto Marvell-based platform. This is the first time in the white box market, and we'll be the first one to port the disaggregated NOS onto Marvell-based platform. And what it means to the customers, so many white box are based on single chipset. I mean, the chipset from the single vendor today. And this will give a greater choice to you. You can use now different chipset for the white box. The first target use case we have is the radio access and carrier edge networks. So the DCSG and the provider edge. These are the solutions we will work with Marvell. We will have industry-leading features, including SRv6 and timing and synchronization. And we believe, together with Marvell, we can provide the lower total cost of ownership. So those are the benefits that you will get from this partnership. So this was the end of my presentation. So now we have Alik from Marvell to talk more about the solution from Marvell. So thank you so much.
Thank you. Can you hear me? Yeah, we want to be heard. So good morning. I'm delighted to be here. For those of you who are not familiar with Marvell, and I hope that there are not too many, we are 27 years old, a company listed on the NASDAQ 100 with the revenues on trajectory to hit $5 billion and more than 7,000 employees worldwide. Marvell is one of the leaders in supplying critical components for telecom infrastructure. Our portfolio includes switches, DPUs, baseband processing units, electro-optics, PHYs, and in the span of last 15 years, we shipped hundreds of millions of units. I think that there is very hard to find a telecom network that does not deploy several components from Marvell. Going to 5G, Marvell solidifies its leadership position. In a traditional run, we supply today to 5 of top 6 OEMs, different products. And for Viran, there's also several engagements, probably you heard in the opening keynote from Vodafone, 2 partnerships that they have announced with Samsung and with Nokia. And both partnerships, they use platforms that are powered by a Marvell system on the chip. So going from Marvell into what happens in the RAN and the changes, transformations that are implied from the transport perspective, as networks become increasingly digitalized and disaggregated, Ethernet de facto is the interface that provides connectivity, and the importance of Ethernet-based networking gear is only going to increase with the insertion of AI, machine learning, cloudification, and so on. So zooming in on the front haul part of the network, that is a change in the transport architecture, we in Marvell, we observe hyper growth there, and it's also supported by market reports that we get from Deloro. And zooming in on this particular place in network, about 80% of the data lives there, and the requirements, the expectation that the connection density will grow 10x, while the solution needs to provide latency 1/10 of what has been with 4G. So as you can imagine, the importance of a transport network is really critical to deliver on 5G premises of user experience. And it actually drives changes to the transport equipment. It needs to provide new functionality, new features that were not there with 4G. One of the things is timing synchronization, that with 5G it happens, with RAN it happens in the network. More robust security solutions, programmable and more elastic traffic engineering options, and scalable bandwidth to provide building blocks for solutions that span from street level gateways or base stations to connecting large cell sites. So for this type of changes in traffic engineering in the transport networks, we introduced our Prestera DX7300 series of switches that has been designed to address this new emerging needs. And specifically, these chips, they promise to deliver state-of-the-art performance, leading security solutions, high degree of intelligence and flexibility that these networks required. Specifically, Prestera DX7300, the family of switches, they are the first switches, and as far as I know, the only switches that deliver timing accuracy that is compliant with Class D accuracy. There is lots of security functionality that built in these chips, embedded MACsec, and also secure boot and storage to protect the image and provide overall trustworthiness to the solution. Programmable traffic engineering supporting newer paradigms such as segmented routing, and even flow and workload awareness that allows to do different traffic forwarding and analytic decision based on EC pre-headers as one example. It's a family of switches that span from 200 gig to 1.6 tera with supporting different port speeds as low as 100 megabits all the way up to 400 gig. So it really fits a variety of deployments from street level gateways or BTS equipment to powering and connecting larger cell sites. And we have our ODM partners that build the hardware, and now we are really delighted to announce this partnership with IPI, having their market leading in telecom space, Oknos, the network operation system, powering these solutions, powering these switches, and we believe that together we will bring tremendous value to the industry, providing a greater selection of solutions and driving and accelerating the pace of innovation. Now, the hardware that we build and also the software will be TIP compliant, so it also expedites the time to the market and alignment to reference designs for the industry. So we're really excited to deliver this with IPI, and we hope that you are going to to get the best of that. Thank you.
So thank you. Well, that's the end of the session this morning. So feel free to help yourself to more food at the back. I'd like to say that you saw quite a glimpse of some of the technologies we had with OFAN, OpenBNG, Phoenix of the disaggregated optical systems, and also with DCSG. We're going to continue some of those talks of those topics in more detail at 12:45 in our session called From Farm to Table. So please feel to come back then and join us and learn more about that then. Thank you very much for attending so early in the morning as well.